folks, as promised, we're going to do some calculus. We're going to do some optimization in calculus. Let's not waste time. This question's on your screen. It says the following. In this figure, point B lies on the line that joins, let me just get a pen here, that joins the point P and the point Q. On that line, we find point B. Then they say, ABCD is a rectangle, so we know immediately these are right angles. And if we need it, opposite sides are equal. So that's also K. And yeah, this was given as K for us. They say DC is K and A, D, and C lie on the axis. So A, C, and D are on the X and the Y axis. Perfect. Okay, so the first question is asking us to determine the length of BC in terms of K. Okay, so we want to find the length of this line in terms of this variable K. Now, folks, BC is a vertical line. If we want to find its length, we already know that the X value at point B is K. We are now looking for this Y value of point B. Now, what did they tell us? They told us B lies on the line segment PQ. Okay, so I'm going to use that. And what's even more beautiful, look at this. P is the y-intercept, Q is the x-intercept. So we're going to start off by finding that equation. The equation is x over 6 plus y over 12 is 1, your dual intercept formula. Okay? Now multiply both sides by 12. Then we have 2x plus y is equal to 12. And then y will be 12 minus 2x. So the equation of this line is y equals 12 minus 2x. Now, folks, what do we want? We want the y coordinate for B. Well, do we have the x coordinate? Let's see. Yes, we've got it as k. So all that must happen is this k must go into this equation to give us 12 minus 2k for the y value. So the height here is 12 minus 2k for both of these. Okay, that was quite easy. We found it by finding the equation of the line. That was for 2 marks, 2 lousy marks. 9.2 for 5 marks. They say now find the coordinates of B so that this rectangle has a maximum area. Okay, so to find the area, we're going to find the area in terms of K, because we have the height of this rectangle and the base here are both in terms of K. So it's a simple formula you learned in grade 6 already. Length times breadth give you the area of a rectangle. So it will be K multiplied by 12 minus 2k, which gives us 12k minus 2k squared as the area in terms of k. Now we go to phase 2. This derivative of this area is going to be 0, where we have a maximum or a minimum. If you want to use one word that describes both, folks, you can just say for optimum. That means it's either maximum or minimum. Now clearly, folks, if you look at the rectangle, the minimum area is going to be 0 if it lies on point P, if it's that line, or if it lies on the x-axis. Okay, so we are looking here most probably at a maximum area. If I differentiate this, I get 12 minus 4k, which is equal to 0. So in other words, I am differentiating this equation over there. Okay, if I make this equal to 0, minus 4k becomes minus 12, and therefore k is equal to 3. Okay, so if k is equal to 3, that's where our area of our rectangle will be optimum. Let's just see if they asked us. They said maximum area for which determine the coordinates of B. Okay, so we've now got the x coordinate, the y coordinate we just have to substitute back. So the coordinates of B will be 3, and you can say 12 minus 6, 2 times 3 is 6, 12 minus 6 is, 12 minus 6 is indeed 6. So if that coordinate pair is at 3 and 6, the area of that rectangle is a maximum. Let's just quickly talk through process here. They did not give you the height, but they told you that the point B lies on a line segment here. So once you find the coordinate of point B on that line segment, folks, any coordinate pair here, this one will be P and 12 minus 2P. A coordinate pair there will be K and 12 minus 2K. Okay, so we had one. We used the same variable there. So let's just make that a Q, just to have a different value. Here we had K. Okay, so once you've got the equation of a function, you have the relationship between its coordinates. And then finally, they ask us, what is this maximum area? Okay, so we go back to our function here, and we make K equal to 3. Okay, if K is equal to 3 in this equation over here, then we get 3 times 12 minus the 6, so 3 times 6, and that is 18 units squared, is the value or the maximum value of that rectangle in our diagram.